Good morning and good afternoon for everyone out there attending the DataON Virtual Academy's webinar. Very excited to be here today again. We've been doing this since the pandemic happened, and I think this is our ninth session of a really ability to share with our audience and our customer the latest technology content related to all the technology that DataON and our partner continue to help our customer with. Today's session, we have two great speakers helping us deliver the content and message. And the topic today is really talking about why you should virtualize Microsoft SQL and Azure Stack HCI and all the benefits you get out of it as a really great workload for the HCI architecture. As usual, we have two experts within the field that we have invited to our conversation and discussion today. We have Brian from Microsoft. He's a senior program manager. And we also have Ken, who is a solution architect from Intel. As you know, both Microsoft and Intel are the two closest partners of DataON, and we want to continue to bring their expertise into the discussion with our customer to share about their experiences and why they believe that infrastructure and the software are really better together. Some of the housekeeping, which I usually do, please make sure you mute during the webinar so our audience and our presenter could discuss. There is a chat window. Feel free to submit your questions in chats and we'll try to answer them as we go. If you need to reach us afterwards, you have our email, and also we all have Twitters, which is a very popular way to communicate. Here's our hashtag. Feel free to tweet us and ask us questions as well. So normally in our webinar for this series for the last couple a month, I try to set everything up as a high-level direction of where we see a DataON direction of the enterprise customer, and the key trend we see in the marketplace is really the concept of hybrid cloud. And the journey that most of our customers are taking in the hybrid cloud journey, and how Azure plays a key role in that process. As we look through the journey of hybrid cloud and hyper-converged infrastructure, you'll see that there are many applications, many business decisions that our IT admins and our customer has to make. And they're not in particular order, but these are decisions you have to make as you go through this journey and make sure that you rationalize the implication and how it affects your organization as you grow. Number one, as I talk to many customers, is really the management of legacy apps and how that infrastructure really impact how your legacy app gets deployed and continue to be used by your enterprise customers. Second is really looking at your definition of, if I want to deploy this workload app, should I put it in the cloud or should I put it on premises, right? There's benefit to both, and there are advantages and disadvantages. We have customers who say, well, they want to put the web application on SQL in the cloud, or they want to put other secure stuff on premise. But ability to move the two around is also important. So defining the application strategy is another discussion we constantly have with our customer, and happy to have that with you guys. Consolidation security, clearly it's a topic that constantly come up, and as aging and older infrastructure continue to get phased out, and new technology comes in like Azure Stack HCI, you want to see how the consolidation infrastructure really changes the way that you guys architect your solution. But more importantly, making sure in that process, security, data integrity is foremost in your decision process. Containers, application, VM, these are topics that currently are very important in the discussion with our IT admins. And how do you make sure you're modernizing those apps and containers to make sure it fits your current workloads? Lastly is, the concept of, hybrid cloud is a great way to bridge the on-premises and the cloud environment. How do you deliver that hybrid cloud infrastructure? And is Azure the right solution to do, which we believe it is, and how to take advantage of these capabilities? So as we go through this journey with our customers, we hope to touch upon each of these categories in our discussion with you guys. Some numbers, right? Clearly the size of the Azure Stack HCI market is continuing to grow. It's a $12 billion market based on IDC. Kubernetes and app deployment are growing, and the growing in terms of people looking at it and growing as the size of market. So we believe that looking at containers is also another key areas. Do people actually consider hybrid cloud? 91% of people surveyed on ESG says yes. IT leader says yes, hybrid cloud is definitely the direction that they like to go. Whether or not it's more hybrid or more cloud or more on-premise is a decision you have to make within yourself. But definitely it is a trend in a marketplace that IT leaders believe will benefit their organization. Lastly, just data growth, both in a data center and also at the edge. You'll see that data continue to grow because of application requirement, but more importantly, many IT organizations are looking at pushing the compute to the edge, so you can really have that balance between a primary data center and the edge data center, and to have that intelligence built in across the board. So all these are facts that people are looking at as they make the IT decisions. As we continue to go towards the journey of hybrid cloud, we believe Azure really has taken a prominent role in driving its hybrid cloud deployment. With the announcement of Azure Arc from Microsoft last year, Ignite, they talked about how Azure Arc really could become that layer of hybrid cloud services. Both allows you to have a multi-cloud environment, whether it's Azure, AWS, Azure, or Google, but at the same time, you can manage your on-premise infrastructure from that layer of cloud services. And that's very, very important for you to say, hey, just because I want a hybrid doesn't mean I have to say specifically buy into one cloud services. You have the ability to choose a cloud service and manage that entire infrastructure from a single layer of management. But more importantly, ability to manage cloud and ability to manage on-premise at the same time is a very important trend, as many customers have multiple locations. So we believe ability to have that concept of edge and Azure cloud in the core are something that is happening across our customer organizations, and the hybrid cloud concept is really the driving factor making that happen. But underneath all that, and we talked about this twice already in our webinar, is the concept of data governance, security, making sure when you deploy these solutions and managing services, you have integrity data in place, backup, DR, air gapping your solution, using the right technology. Do you have a DR backup to Azure? All these are relevant conversations that we'll constantly have with our customer to make sure that not only talking about refreshing your infrastructure, but talking to make sure that your security, your data governance is in place. One of the key technology, clearly, that DataON partners with Microsoft is the concept of Microsoft Azure Stack HCI, which we have been talking about for the last 2 years, and really we've been on this journey with Microsoft for the last 10 years. But we do absolutely believe that the concept of hyper-converged infrastructure is a benefit to our customer, and Microsoft really have gone a long way to ensure the stack is the right stack. Taking a solution from DataON with the validated hardware, running in Windows Server 19 to get the benefit of unlimited Hyper-V virtualization, software-defined storage with Storage Spaces Direct, and software-defined networking with RDMA, virtual network, are all benefits you'll get with the software-defined network of Azure Stack HCI. On top of it, Microsoft continue to invest in the capability of Windows Admin Center, an ability to you have a single pane of glass to manage your infrastructure across the board and have that visibility. And with Must, which is an extension that DataON built as a software, you're now getting more visibility across your disk alert systems, an ability to really monitor, manage, and predict the future of your infrastructure. Finally, with Azure Stack HCI, is a seamless connection for you to take advantage of all the hybrid cloud services. Azure Backup, Azure Site Recovery, Blob Storage, AD. All these are capability today is within Azure, and with Azure Stack HCI and Windows Admin Center, you have the extensibility of using these services. I always tell customer, a lot of time, Microsoft Azure Stack HCI and the capability is the best kept secret, because a lot of people doesn't know that today, if you have Windows Server Data Center license, you essentially have the bits and codes of the solution that we're deploying for all our customers. And many customers are recognize the benefits, and you'll see that this is a very simple snapshot of customer base that have deployed DataON-based solution for Azure Stack HCI. and these application and customer span across multiple verticals, whether or not you're nonprofit federals, you're a educational SLIC customers, your banking organization that wants the best security and resiliency for your banking application, manufacturing, medical. And you can see that across the spectrum of verticals, customers are deploying Azure Stack HCI in their organization and using it to run their workload for their enterprise applications. And workload is what we always continue to emphasize, not talking about just the infrastructure, but how we build the infrastructure to make sure these are optimized for your specific workloads. 3 weeks ago, we talked about converged storage, how Azure Stack HCI really helped you to deliver a scalable storage architecture for petabytes of storage with Microsoft Azure Stack HCI supports. Last week, we talked about Edge, how having an Edge solution that's 2 nodes, 3 nodes allows you to run your workload as a branch office and really deliver that compute to the edge. And we had a great discussion there as well. And this week, our goal is to give you guys a understanding of why we believe a virtualized Microsoft SQL Server is also a great solution to run on Azure Stack HCI. And Microsoft and Intel will share with you guys that concept and why they believe making the right architecture work. And moving forward, you're looking at other workloads that we'll be talking about, like VDI, WVD, on the entire Azure Stack platform. This is Brian from Microsoft. Talks about SQL Server on Azure Stack HCI. Go ahead, Brian.
Hey. Hold on. I'm having some phone issues.
We can hear you.
Okay. Yeah, I'm trying to get it so it's not me holding the phone to my head. 1 second.
We're ready for you. So you just forward a slide and start chatting. Brian, are you there?
Yeah, I'm here. Just 1 second.
Hey, Howard, we're waiting on Brian. Did you have any questions for me? Anything you want to call out?
Yeah, you know, as we looked at the content you have on the Intel side, I think that it's just a lot of technology innovation that's happening today for the SQL workload. And I think for me is as you guys continue down this path, you know, what are the key optimization you're seeing happening that you feel like could be a game changer in the technology that makes this thing just runs like crazy performance-wise?
Ah, gosh, I think I'd be starting to do some future-looking stuff here.
Okay, how's that now?
You sound great, Brian.
Yeah, I can hear you. Welcome, Brian.
Yeah.
Welcome to the party, man. We missed you.
Yeah.
Thanks.
Go ahead. You could forward the slide and you can start presenting.
All right. Okay, so today we're going to be talking about SQL Server 2019 running on Azure Stack HCI. We're going to address some issues of, or demonstrate some issues of performance, high availability for SQL Server running on Azure Stack HCI, and how we integrate with some Azure services. And just a quick overview of SQL Server 2019, which is one of the industry-leading relational database systems, and one of the most secure, and all at the price of 1/10 the cost of Oracle. Oh, sorry, animations. So SQL Server 2019 is designed to solve a lot of modern data challenges, whether it's running across multiple platforms, high availability for your mission-critical servers, built-in handling of machine learning and extensibility to other types of languages, data virtualization, which is addressing different systems across your state without the need to move data and expensive ETLs, and intelligent performance for your queries. So they adapt and improve without a lot of time-consuming performance tuning. So hyper-converged infrastructure, Azure Stack HCI, with SQL Server helps solve some of the challenges that businesses face today, whether it's rising data center costs, which can be addressed through HCI by having higher server density, lower cooling and power costs, expensive ETL for integrating external data sources can be resolved through the use of, like I mentioned, data virtualization, and the siloed relational data and what we call big data or unstructured data again can be addressed with this data virtualization concept of Polybase. It's time consuming. A lot of DVAs spend the majority of their time performance tuning queries. We take a lot of the work out of your hands on that one and allow the DVA to focus on queries that deliver maximum value for the business. Meeting of data security and compliance standards, and keeping data and applications always available using high availability options, and performance is affected, which gets affected by unreliable I/O. This is a major problem for applications that are recently virtualizing. Is the I/O element, which is now usually on a shared infrastructure. So I'll talk more about the performance that we have there, and consistency across languages and platforms. IT staff can be trained and are familiar with T-SQL, and then they can use that through Polybase to address any number of different data platforms that are out there. And many barriers to creating intelligent apps with AI and machine learning, again, which we make simple. So SQL Server 2019, unlike some editions in the past, we have simplified matters, and there's now only 3 different editions. Enterprise, which is the sort of all-you-can-eat buffet, and Standard, and Express, which is our free tier edition. And the idea is that these scale as your needs for scale grow. They naturally align with one of these editions. And Developer, which is free and available for development. Yeah. One of the things that we introduced with SQL 2019 was new software assurance benefits. So we get a sync node on-prem that you can use for high availability, an additional sync node on-prem that you can use for disaster recovery, and then from on-prem to Azure, you get an additional disaster recovery node for use. So These are all free, so you can get up to 3 free unlicensed or 0 license cost nodes for your initial replica. In terms of performance, one of the big features that we had at SQL 2019 is hybrid buffer pool, which makes use of persistent memory such as Intel's Optane, and is used to really enhance the performance and scalability for much higher I/O throughput to the engine. And we can eliminate page latch contention, which is another common problem in TempDB. We can eliminate it entirely using our in-memory TempDB in-memory optimized metadata memory for TempDB, which takes the system tables in TempDB and converts them into in-memory OLTP tables, and thereby removes all the locks and latching, dramatically accelerating the workload. And so there's a duplicate slide here. Okay, and one of the things that's somewhat unusual is that the hybrid buffer pool, which, as I mentioned, is available in both Standard Edition and in Enterprise Edition. So we have here an example where we achieved a speed up of 16 times over SQL Server 2014 Standard Edition, and over 3 times faster than SQL Server 2019 Standard Edition without a hybrid buffer pool. So dramatic speed up there, and a performance feature that's available in Standard Edition. So Azure Stack HCI, storage, as we've mentioned, is critical to running of any VM, especially in a HCI setup. And this is from a storage review, and it gives a head-to-head between Azure Stack HCI and VMware's vSAN, and you can see a huge increase in the amount of random 4K reads, so over 4 times the amount. This is a comparison that was done on the same DataON hardware, and we can see the massive difference on the same hardware. And just another example, and it was just using a realistic SQL Server workload, and we can see a 6 times improvement in throughput. So Azure Stack HCI, as you can see, has incredible performance at storage level. And just some performance guidance for running SQL Server on a VM. We recommend such things as lock pages in memory if you're running Windows, instant file initialization again on Windows, SQL query, standard SQL query best practices. We have a number of guidelines that we document for SQL Server on Linux, which is unusual for us because there's a lot more OS tuning involved. With certain optimizations that we've built into the RHEL 8 XFS file system, and then we have the option of file snapshot backups in Azure if you run your database files from Azure Blob Store. And the rest of these would just apply to any SQL Server, but they apply equally for VMs as well. As you can see, we've quite the range of high availability and disaster recovery options. From our simple resilience to a guest or physical failure of the host, which is handled by Windows Server Failover Cluster in HCI, right through to more standard failover cluster, which gives like instance level protection. We're in the seconds to minutes of RTO, right through to mission critical high availability, which is availability groups. There we're into seconds of RTO with no data loss, and we can recover from unplanned outages. Here's just an example of Azure Stack HCI, and we can see in this case it's spanning across, and we have a node in Azure as our DR node. It's using accelerated database recovery, which allows for faster starts. We even have clusterless availability groups. If we want, no need to set up a Windows Server failover cluster. It's not required. This is merely for load balancing of readable secondaries, and you can even have these cross-platform between Linux and Windows. There is only manual failover, obviously because there's no cluster. All right. So Azure Stack HCI, as mentioned, integrated with Azure itself. Main integration at the moment is around backup. So the Azure Backup Service will back up SQL Server on-prem or in the cloud, and also with the Azure Blob storage, as we can run backups to URL to Blob storage, or we can actually serve our SQL database files out of Blob storage, and a number of other SQL-related services in Azure that work well with SQL and Azure Stack HCI. Azure Synapse, which used to be called SQL DW, Azure Data Factory, which serves some of the functions of SSIS, and HC Insight and Databricks. All right.
All right, so I want to talk a little about, Azure Stack HCI is, the building blocks. We'll get to that a little later in the materials. But, I obviously understand it's anywhere from a 2-node deployment up to a 12-node deployment, I believe. Typically a homogeneous type deployment. All the servers look like each other, although you can stand up different clusters with different configs for different workloads. But within those are a number of Intel ingredients. And I want to talk a little bit about, processes in general and how that relates back to something like Microsoft Windows Server or Microsoft SQL Server. We typically have a license per core type model. So it's not always, more cores isn't always the answer. Sometimes it's more about performance per core. We're finding that right balance of performance and core counts. Similarly, I want to talk a little bit about Intel Optane technology, both in SSDs and both in persistent memory. And a little bit about our solid-state drive family of products as well. Obviously, current climate, I'm not getting out very much, but even prior to this, in the last year, 2 years, 3 years, out in public at shows or with customers, a lot of folks are surprised to learn that Intel makes SSDs. I didn't know this. And how they've evolved over the years, right? And just talk for a minute about kind of the bottom right corner there, where we say 3D NAND and QLC SSD. What's that really mean? SSDs were initially developed as kind of drop-in replacements for hard disk drives. So you came up with a form factor, typically 2.5 inches wide, either 7 millimeters tall or 15 millimeters tall. There's only so much real estate you could use to actually put capacity in there. And so 3D NAND, it's two-dimensional in the sense that original SSDs were kind of planar. And now we're able to stack layers and layers to actually put more capacity into there. And so that was one angle to get more space into that fixed area, that fixed volume now, if you will. And then this concept of QLC, which actually means quad level cells or 4 bits per cell. SSDs first came out, it was 1 bit per cell, was on or off. Some number of electrons are in there. You can determine that as a 1 or a 0. MLC came along and doubled that. TLC, or 3 bits per cell, was a 50% improvement over MLC. Now we can do 4 bits per cell. So think about just how dense we can get into that same physical footprint. So you're actually storing up to 16 different states to represent 4 ones or zeros being on or off, all within one little NAND cell. Let's see here. Okay, so I'm going to switch over and talk about CPUs for a little bit here. A lot of people I've talked to, Intel's a chip company. What have we been doing in this space recently? In the last couple months here, we've released into the market some new refreshed versions of our 2nd generation Intel Xeon Scalable processors. And I mentioned this as specific to SQL Server here. This section on the left there, if you will, peak frequencies for high performance usages. SQL Server is designed to scale. It will certainly use, if it can, it'll use all the resources that you toss at it. But in certain situations, you may be like a SQL Standard customer. You're only entitled to 24 cores. Or maybe you're doing something with a fixed degree of parallelism. And so there's an aspect of performance per core that comes into play. Sorry, how was there a comment there? Or? No. All right. So again, this is about finding that balance. And in a hyper-converged solution like Azure Stack HCI, you do have to spend some cycles outside the application workload for things like cluster management. There's data being replicated or read remotely. Similarly, you may have other workloads in your deployment, independent of your SQL Server application. But just again, when you're putting one of these together, it's a design consideration, right? We have a wide variety of parts and components, and we're going to kind of focus on what for this webinar is more specific to SQL Server. And so I want to take a minute or two to talk about Intel Optane technology. I think there's still I won't say confusion, but there's still not maybe widespread recognition of what this really is or what it means. But it's really the combination of a couple of building blocks. There's something called 3D cross-point memory media. This is a new form of non-volatile media that Intel co-developed with Micron. And while it's silicon-based, it is transistorless, unlike traditional NAND. So that gives it some interesting capabilities and similarities. You'll start seeing that it's got attributes that more resemble memory, but it also has attributes that resemble storage. And you start to blur the lines there a little bit. And so when we couple that with memory controllers or some Intel developed ASICs, it comes to market in 2 different form factors. It comes either as a solid state drive, which we call our Intel Optane SSDs, and it also comes in what looks like a memory module there. It actually is a DDR4 compatible layout. We call that Intel Optane persistent memory. So really what that means is that 3D cross-point memory media is embedded on those devices. And again, the one is an SSD, sits on the PCIe bus using NVMe protocol. So kind of just plug and play with traditional NVMe SSDs. In the Intel Optane persistent memory modules, those have to be paired with an Intel 2nd generation Xeon Scalable processor, and they sit on the memory bus alongside the DDR4. All right, so just a little bit more info on that product and how it can apply to SQL. Optane persistent memory, again, DDR4 compatible, looks like memory. Comes in slightly larger capacities than DRAM can support today, starting at 128 gigs in this generation and topping out at half a terabyte. And like the name implies, it's persistent, unlike traditional DDR4 DRAM, which is volatile. And so I mentioned it's starting to blur the lines here in terms of memory attributes and storage attributes. What's kind of unique to this device in the market right now is you can configure in the system to be a memory extension, if you will, paired with some DRAM. The OS will see a amount of capacity that's reflected by the Intel Optane persistent memory, but in front of that is a cache of DRAM. That's both a read cache and a write back cache. So you can expand in an affordable manner the amount of memory available to the OS. Or you can configure it to be storage, and it shows up in is a persistent memory device in Device Manager. And then you're allowed to actually format that as traditional block device, or what the really cool kind of new stuff is what we call DAX, or direct access, and treat it like a memory map file system. And we'll get into why that's beneficial, especially for SQL, as we get into some of the future slides here. And then you can also actually have it run in both modes at the same time. Just kind of set a slider bar that says, I want it to be 100% memory down to 1% memory. And in that case, you can actually have some for storage and some for that extra memory. All right. So the other product we mentioned was Intel Optane SSDs. Again, that same 3D crosspoint media, but presented as NVMe SSD. Some advantages over NAND SSDs here: typically lower latency, typically much higher endurance, a little bit smaller capacity-wise, but it does come in. It's a standard U.2 or add-in cards, and kind of supports all the traditional bells and whistles that our NVMe SSDs built on NAND do. Okay, so I was going to take just this slide here to talk a little bit about how you can improve an Azure Stack HCI deployment with Intel Optane technology. And so Azure Stack HCI can be deployed a number of ways in terms of local storage to the system. You can do single tiers with all NVMe SSDs. You can do 2 tiers with a flash tier as a kind of a cache. And you can even do a second tier of lesser grade flash, or a second tier of even hard disk drives still. We wouldn't recommend that for SQL Server. We'll talk a little bit about the demands of that workload. Would kind of steer you away from that one naturally. But you could deploy in a low NVMe count type deployment, say 3 or 4 NVMe SSDs. You could actually accelerate those with putting an Intel Optane SSD in front of them into the cache tier. That's one way you could deploy Optane to kind of accelerate things. Another becomes kind of a capacity play for maybe you need to have a larger working set. Maybe you want to start running larger databases or more tenants. You can add Intel Optane persistent memory into the system to increase the overall memory footprint within the OS itself. Or similarly, I talked about that mix, what we call mix mode. You could actually put persistent memory into the server and configure it as both memory and a cache device. So again, a little bit of storage acceleration with some memory expansion at the same time. So the next slide kind of illustrates, what does that memory extension look like? Typically we see kind of the sweet spot. If you go look at the Azure Stack HCI online catalog, 384 gigs of DDR4 is probably the median in terms of how servers are equipped with memory, and that makes sense. 192 gigs per socket. You could do that with 6 32 gig modules per socket, or fully populate the server with 16 gig modules. But this example here is meant to show, okay, I have a system with 12 16s, or I had a system with 384 gigs. For about the same cost, you could actually reduce that to 12 16s and put in 512 gigs of Intel Optane persistent memory. And the OS is going to see that as 512 gigabytes. And you've got that 192 gigs of DDR4 sitting in front of it as a cache. And then, so that handles the memory part of the subsystem. And then you can still go configure storage. Again, cache tier there. Optane, again, provides, and this is an interesting distinguishing element here. If I look at the capacity tier first, we talk about, SATA SSDs, potentially a slower interface there than NVMe, but, perhaps a cost savings, or just perhaps a system capability count, how much you can put in, or that 4-bit per cell SSDs. What's really different about the cache tier and the capacity tier, think of the cache tier as absorbing all of the writes and kind of insulating, those lower endurance SSDs in the capacity tier. And that's important. One, because you can opportunistically destage writes. You can extend the life of your capacity SSDs, and you're also to some extent kind of masking their own latency limitations as compared to what the cache tier devices can do. So what does that but then how does that really impact a SQL Server workload running, or where can SQL actually leverage some of those Optane technologies. And I'm going to get to that in a couple of slides here. So we're going to start with the Optane SSDs first, right? I mentioned earlier that to use Optane persistent memory, you need a system with an Intel second generation Xeon Scalable. So when I say for systems that don't support persistent memory, we're really talking about something pre-second gen Xeon Scalable. So in that scenario, you can use SSDs as fast storage, but you would strategically place them, right? You could say these are good because of their low write latencies, or high ops at lower queue depths. These might make the best sense to strategically insert it as temp database hosting or transaction log hosting. Again, so anything that's logging or scratch area where the application would benefit from a device that's more tailored to processing those types of activities. And so again, the graphic there is meant to illustrate, in this system we've got our CPU, we've got our regular memory, we've got our PCIe bus. We can attach an NVMe SSD that's one of our Optane SSDs that uses the NVMe protocol. That's roughly plug and play. That ecosystem's matured over the last few years. 5-6 years ago when I was first starting out in our SSD group, those are a little harder to find. You were kind of restricted to adding cards, but now I would say they're pretty mainstream, pretty well understood. And then similarly, you can put the rest of your database files, whether that's, when I say MDF, your master data file, or NDS, secondary data files. Those can go on traditional 3D NAND SSDs, where you still have a, SQL Server, again, running at scale, can drive quite a bit of parallel I/O. And those are well suited for that workload. And from an endurance perspective, most database workloads, at least at the data file level, are going to be reads versus writes. So they are just a good natural fit. Where things get interesting is going to be with SQL Server and Intel Optane persistent memory. And so I can't take credit for the slide. This is something Microsoft actually put together and helped come co-present to our field a few months ago. But there's multiple ways you can use persistent memory to enhance kind of the SQL Server experience, whether it's larger workloads, whether it's acceleration of workloads. And kind of working our way from the top right, maybe to the bottom left, we'll start with kind of the traditional ways. I mentioned earlier, you can set up persistent memory as a block device. And then the SQL engine, just as its regular kernel I/O, manages its data files and its log files. You can certainly do that. The kernel I/O, however, adds kind of a latency hit, and it actually can mask some of the improvements of the media. So in some cases, you may actually be better served using an Optane SSD there. But depending on capacity needs or sizing or all outright performance needs, it's an option, and it's applicable to all versions of SQL Server. Again, it's just a block device. Don't need a special version or newer version of SQL to go down that path. That second feature here is persistent log buffer. This is something that was introduced in a service update to SQL Server 2016. And what this does is what used to be in memory, what they used to call tail to log, was now written to a persistent module. So there's commits for OLTP workloads happen right away, and you don't have to worry about them getting flushed to the log because they're now persisted. And you can now basically increase your transactional throughput rate. Now, for SQL Server and Optane persistent memory, this is an interesting paradox, right? That log cache is only a handful of megabytes per database. Persistent memory only comes in 128 gigs or larger increments. So where I find this one interesting is perhaps virtualized environments like Azure Stack HCI. You can actually carve up that 128 gigs into smaller increments, virtualize it, if you will, call it virtual PMEM, and allocate it to the VMs. Those VMs see their own persistent memory device, and they can set it up for use with persistent log buffer, and get an accelerative benefit out of doing so. Okay. Then we get into SQL Server 2019, and a couple of new features introduced there. And this is what this is kind of really our first intercept with using persistent memory, what we call application direct mode. And that's what I mentioned earlier, uses direct access or DAX file systems, which NTFS supports. But the idea here, and of course no Linux kernels, the idea here with Enlightened.io, you'll see that SQL engine goes directly now to the data files and the log files. It bypasses kernel I/O. And there's a speed up to be had there, just because that kernel I/O does have a little bit of latency overhead with it. It's kind of doing traditional storage, traversing the traditional storage stack versus leveraging a memory map file system. That features Linux only. And then we get to the bottom left, something called hybrid buffer pool. And that applies to both Windows Server and Linux. And this is potentially interesting to people that have either a DRAM limit in their system or standard edition users that can only have a buffer pool of 128 gigabytes. Again, you could deploy this in a virtualized environment at a much smaller scale. We can slice up persistent memory into smaller virtual PMEM devices for the guests to use. But the idea here is, in a traditional buffer pool, it's a portion of RAM that's been allocated to SQL Server, and it is both a write-back cache for dirty pages and a read cache for clean pages that have been read off of storage. And in hybrid buffer pool, SQL Server is intelligent enough, for SQL Server 2019 is intelligent enough to ascertain that the page I'm accessing is clean and it's on a PMEM derived volume. So I am going to read it directly from persistent memory rather than read it and then copy it into DRAM and take up some of that buffer pool space. So in effect, you're now able to use that DRAM portion for dirty pages that need to be written back, or even the hottest pages that are coming off of persistent memory if they're frequently accessed. It's smart enough to still store those, but bypass that traditional read from disk, store in DRAM before it can be used for first page accesses. All right, and so this is kind of my eye chart page on those three features I was talking about.
Hello?
We could,
Hello?
I'm going to...
Hey, Brian, are you there?
Is that Brian?
I am, yeah.
No problem. Well, Ken's presenting. We'll go back to you right away after Ken presents.
Yep. Saved you lots of time, Brian. You'll be fine. All right, so this is kind of the deep dive on those three features I mentioned, which are kind of specific to Intel Optane persistent memory as it relates to SQL Server 2019. My last slide, and this is something Howard, you may want to comment on as well because you're a partner in this program. The Intel Select Solutions brand, we launched this, gosh, is it 20, and years are flying by now, late 2016 with the launch of our, what are called our first generation Xeon Scalable processors. Simplified, reference designs, deployment guides, benchmarking guides for kind of common application stacks. And Microsoft SQL Server was one of the first ones we did. At the time, I believe it was Windows Server Software Defined. It hadn't yet been rebranded as Azure Stack HCI, also part of that program. And so this is really just even in our, what I want to call out here is it's meant to be kind of an easy button. Our partner ecosystem, DataON included, we share our designs, our results. We'll do some co-engineering to bring to market something that's well suited for running a particular ISV software stack. In this case, we do have offerings for both Azure Stack HCI, Datacenter, and edge deployments. Similarly for SQL Server, both on Windows Server and on Linux. And it's meant to take some of the guesswork out of this as you're trying to design a hosting platform, and give you kind of a guaranteed minimum level of service if the recipe and steps are followed kind of as prescribed. And then our OEM partners usually take those as a baseline and say, hey, well, we can do better. And I think, Howard, that's probably a good segue back to you if you want to mention what DataON's taken on these designs and done.
Thank you so much, Brian. Thank you, Ken. Hey, believe it or not, all the data and best practice you share are something very valuable to all our customers. We have been architecting SQL-based HCI for the last, let's say, 3 or 4 years, but there's a lot of insights that you presented in your slides that's actually new to me, to be honest with you, and how the provisioning is set up, how you want to make sure these features are enabled, because a lot of our customers are necessary DVAs, right? They're infrastructure admins. They want to run SQL as a workload in their environment and make sure they understand these concepts, and these tuning and setup, to me, is very important for them to make sure they don't make a mistake. And my assumption is, having these content now we can share with our customers and our enterprise IT admins to make sure that when we talk to them, they're aware of these capabilities and features to make sure they optimize for. Ken and Microsoft, I guess, Brian, I know you guys know each other. I guess the question is, as the journey continue to make sure SQL works well on Azure Stack HCI, I have to assume there's a lot of collaboration between Intel and Microsoft to ensure that both from a software level and a hardware level that there is a good optimization happening. Am I right to assume there's a lot of discussion between the two companies always to make sure that as a complete solution, the technology and the software are being optimized on a regular basis?
Yeah, I mean, you could say that, right, Howard? I mean, we have people that Intel employees that are stationed in Redmond at Microsoft, working side by side with the engineers at Microsoft. So I mean, it's one of the oldest partnerships we have, right? It's 20 plus years between Intel and Microsoft. And that's not just, I mean, that's the Windows Server team, the SQL Server team, and even the work we do with the Azure Stack family of products. It's obviously an umbrella that Azure Stack HCI falls under. I mentioned earlier, the Intel Select designs we do. I actually can't share those with you until Brian's reviewed them. So we do tend to work together. And similarly, it's like, we listen to Microsoft's needs on if hardware could do ABC or XYZ, or there's features, I would say, capabilities. It's kind of just a way of oversimplifying things. But where do they want to go next? Is it, there's more and more technologies that are getting built into the silicon, and then coupled to the software. I just think that coupling is getting tighter and tighter as time progresses.
Got it. Hey, Brian, looks like there's a question from the audience for you. Can you see the question, Brian?
I can see the question. So it's if a local site-based application works with a local 2016 or 2019 database, are there any concerns with that application working with Azure-based SQL? Well, it depends on the flavor of Azure-based SQL that you use. For our PaaS or platform as a service, there are sometimes some additional restrictions. VM IaaS will work more like an on-prem or a colo type configuration. Hopefully that.
Yeah, I'd say maybe a latency concern too if your clients are used to working locally versus going out across the WAN perhaps. But
yeah, good point. Yeah. Good point. Very chatty application that could be new.
Yeah, and also, believe it or not, we're in real-time conversation with many of our customers that are really seriously considering, because I know for sure, tomorrow we have a conversation with a customer who's been running SQL on a traditional SAN, and they believe it's time for them to move it to a hyper-converged infrastructure running Azure Stack HCI. And the question they come up with is like, hey, okay, we're running 2008 SQL and 2012. What is the benefit for us to move to the latest 18 or 19 SQL? And there's these questions come up. And also, just because you have a infrastructure hardware, it doesn't necessarily mean that everything will run perfectly, because there's a lot of tuning and optimization that needs to happen. Do you see that happening a lot with your talking to customer Brian and Ken, that just want to make sure that it's in tune with their workload and making sure that there's a lot of best practice that needs to be applied as they run a new SQL application onto a new infrastructure?
Yeah, I hear this a lot. If they're on 2008, we've gone past our end of life. So those customers for sure, but also even 2012 is extended support, and we tried to take out one of the things that was really a stark difference to me is if you look at any of the older configurations, we have like a giant list of trace flags and configuration knobs and so forth that you need to tune on your SQL Server in order to maximize the performance for your particular environment. And you really don't see that quite so much anymore. So we're getting more closer to working out of the box type solution. It'll take best advantage of the hardware available.
And that's important, right? Because the challenge many of the customers that we touch faces, they're IT admin. They don't necessarily have a SQL DVA on staff anymore that knows what you just described. In the early days, a lot of tuning and testing. So what you're saying is by them moving to a more recent SQL software, they could probably get a lot of advantages of what you guys have out of the box versus have to go and hire a DBA to go do tuning. Is that what you're saying?
Well, I don't think I'll be putting any DBAs out of jobs necessarily, but yeah, and taking care of a lot of the easier stuff, and a lot of times people have larger and larger SQL estates to manage now. But only a select handful of these need a kind of very much a hands-on approach. So really frees you up for that. I had a comment just recently where an IT admin asked me, he said, I just installed it and I haven't had to change anything or configure anything or tweak anything, and it just works. Am I doing anything wrong? I said no.
That's great. That's something I think many of the IT admins would love to hear, right? Because they're constantly trying to balance the two. Is that what you're hearing, TJ?
Yeah. Yeah, I was going to say, I have there's an entity I work with, I guess I can't say the name, but they were a, kind of an open source Linux-only shop, and I had mentioned to them that, hey, SQL Server runs on Linux now, and you were mentioning, the need for doing some backups of your prod database, which is some of your legacy window box, or, but anyway, I said, like a couple hours later, he's like, oh yeah, I found the container, downloaded it, it's up and running. And a few months later, I'm checking with him, he's like, oh yeah, that thing's been, I haven't touched it, it's been doing everything I needed it to do for, hour or two investment to set up. So I think to Brian's point, the DBAs can now support even a greater footprint because Microsoft's just evolved some of the telemetry, the insights, the ability to more rapidly diagnose, or even in some cases, alert you ahead of time, or auto, or even self-correct in some cases if something's misbehaving. So it's gone from or even like the Linux setup, right? I mean, Windows you can do unattended installs, but you got to do while you're sitting there answering a few menus. Linux, it's yum install and good to go. So I think a lot of the more menial tasks I think are being more automated or solved or fixed for free, and then that leaves kind of what I would find the more interesting challenges, up to the DBA or support people.
Got it. So this is good. I think these are type of information conversation that our customer, the IT admin, love to hear, because they continue to have to juggle multiple roles, and clearly SQL is a workload that they all have to tackle, and knowing from Brian, you guys, that a lot of optimization is being done and make it more easy for them. It's a good thing to know for them to continue to adopt the technology. Brian, Ken, thank you for jumping in today to share your thoughts and content with the audience. Trust me, a lot of people appreciate it. We get a lot of feedback saying, hey, continue to do technology-based content because we appreciate it. So thank you for your time, and looking forward to talking to you soon. And I'm sure the couple customers I have will probably ask you more questions, Brian, and we'll reach out to you. Thank you so much for your time.
Yeah, absolutely. Thank you.
All right.
Thanks for the
Thanks,
opportunity.
guys.